Got the 4 tables for a square. So this is called a square. Okay, we've got oblong or rectangle, 2 tables, and round, we have 1 table. So if you look at your book and you move to the first table is on page 507, and it's figure 5. I'm going to move this over a little bit because I've got 4 of them to put underneath this rectangle. Figure, and the figure on page 507 is 15.7. It says square. Turn the page. Figure 15.8 is square. Cross page, square. 15.9. Turn the page. Next one's 15.10. So there's the 4 tables for the square. And then if you go to page 511, it says rectangular tied column, 1511. Turn the page, 1512 says rectangular tied column. And the last one, if you go back a couple pages to 515, you've got 1513 round. So there's the 4 of them for rectangular, 2 or 4 for square, 2 for rectangle, and 1 for round. Okay, they're all the same, basically. If you look at the table, they're all set up with exactly the same format. So what do? If you look at it, take a look at the table. If you look at the vertical or y-axis, it is factored compressive load kips. Factored compressive load, PU in kips. So that's the vertical axis. If you look at the horizontal or the x-axis, it's eccentricity. Eccentricity in inches. Eccentricity, distance off center. We've talked about that before. Did it in 3360. We've done it a couple times actually in this class. So there's a 2. Then you've got a curve. A bunch of them. Okay, and on that curve is a leader. The leader goes up to a description. So it's going to have the size. So let's say I'm just going to put something that has nothing to do with your text, so don't go looking for it. Tell you the size. Okay? If it's round, it's going to be 1 number. That's the diameter. If it's a rectangle, it's going to be 2 numbers. That's the width and the height. If it's a square, it's going to be 1 number. That's the same for both sides. Okay, then it tells you what kind of rebar it has. Say 4 number 5s, and then it has a percent of rebar. So what you do, pretty simple. You got three variables. First variable is the load. Second variable is how far off center. And the third variable is the size of the column. So we're going to go with what the book does, but you can use it in any, if you have two variables defined, the third one is obvious. So here we'll take the load, move over, find the eccentricity. There's where the 2 cross. You go up to the right to the very first curve. Follow the curve to the leader. follow the leader to the description, and write down the description. So that's how you operate with that. Now, we need, it looks like it's pretty obvious the size is given. How do I find this? And how do I find this? That's our only calculations we have to make. So all you've got to do if you've got those two numbers is use a piece of paper, a triangle, something. Find the number associated with PU on the vertical axis, run a line across, find the eccentricity, run a line up. Wherever they cross, make sure you go up to the right on an angle, hit your first curve, curve to leader, leader to description, and write it down. Okay? So, the calculations. Now we've got calculations. So, why don't we define each of these tables so you know which table to use. The biggest variable is the shape. Okay? So if the problem says a square, you got those four figures to worry about. Problem says a rectangle, you've got these two. And if it says it's a round column, you've only got one. I'm going to tell you right now on a test, for me to use a square is pretty difficult because you've got too many choices and I can't herd you into the path I want you to be in. So most likely on a test we're going to either have a rectangular or a round column. Okay, so given that, let's look at what makes you choose one. Okay, if we look at it, let's go to the very first one. It's a square column. And now I'm going to write some letters here. F, let's write them down. FC prime and FY. FC prime and FY. FC prime and FY. Okay? If I look at this thing, find me a pen that works, and I look at that table, it says 60,000 and 5,000. $5,000 and $60,000. I'm going to do what they did. They have those numbers. Okay, I'm going to go to the next one. 5,000 and 60,000. Go to the next one. 6,000 and 75,000. And I'll go to the last square one, which is 6,000 and 75,000. So it looks like I got two areas. I got a 5 and a 60 takes care of these two tables, and a 6 and a 75 take care of those two. Now go rectangular, 5,000 and 60. Move to the next table, 6,000 and 75. So that's a pretty easy one for me to manage. I can tell you it's a rectangular column. I can give you the specifications of the concrete and the steel, and you're down to one table that you can possibly use. And the last one is the round, and it's 5 and 60. And there's only one choice there. So if you miss that one, we've got a real problem. You only got one choice, and you picked the wrong one, you've got an issue, I believe. So these are the two that probably you're going to see on a test. I can define which table to use here by the spec. This one only has one choice, so you've got to use it. Okay? So what differentiates this over here now? I got myself a problem over here. I've got 2 5s and 2 6s. How do I get to it? Okay, it's going to be the load. Okay? The first one goes from 0 to 900. The second one goes from 300 to 2100. Okay, we got a lapse from 3 to 9. These two tables could be used both. I'm not going to give you one on the test, I'm telling you that right now, but what you would do is you look at which one makes the most sense. Okay, if it's real close to 6 or so, I probably would take a look at both of them and see how the two vary as far as the member that you would choose. The next one is 9, and it goes from 6 to 6,000. It goes from 600 to 6,000 kips. And the next one is square column, goes from 2,000 to 10,000 kips. So basically it's load. And the last two we don't have to worry about, because once I give you the spec of the concrete, you've got the table you have to use. So these are basically where the load falls. If this load was 4, you could use both, 4,000. If it's 7,000, you got to use this one. 10,000, you have to use this one. If it's around 800, 900, 1,000, up to 2,000, you would have to use that one. So the answer should be fairly close as far as if you spend a little time and you look at the table and you make sure that you've got the numbers right, I think you're going to end up with about the same section, whichever table you use. So, for you, worry about the shape, worry about the spec, and then you got to worry about P, U, and E. So how do we handle P, U, and E? Well, let's do a problem. That's probably the easiest way for me to explain it. And then you've got a problem or two to do. You're going to do 14.1b, or excuse me, you're going to do 15.3b, D, and H. So I'm going to go ahead and write mine up here. 15.3a, 15.3, and 15.3. So let me take a look at the problems. Make sure I don't do what I think I'm going to do. So let's go to the back of the table. Yeah, that's right. So I'll do A there. I'll do E. I'll do F here. Okay? And that gives me that one and that one. And then I'll do H. H, I don't want H. I might as well do, yeah, I'll do I here. So we're going to do 15.3a, 15.3f, and 15.3i. And if you look at them, hopefully you've seen it, hopefully you're following me pretty well. If you look at them, the first one says the minimum size square. If you go down to the second series, which is D through F, it says size of rectangular. And if you go down to the G through I series, it says round. So we're going to do one of each of the three. So let me look at the first one. I'm going to do A, and it says for me, I have axial compressive loads. P live load of 80. P dead load of 100. I've got M live load of 30. And M dead load of 25. Okay, if you look at that data and you look at the table, at this point, I don't see anything I have written on the board that has anything to do with PU, in E. So you've got two things to worry about. One is you got to take your data and find PU. Same as we've always done. PU equals 1.6 live plus 1.2 dead. Okay? So there's one of them whipped. So let me do the math. 1.6 times 80 plus 1.2 times 100. I get 248 kips. That takes care of this column. Now, I'm given M in service moments. 30 kip feet, 25 kip feet. Okay. Hopefully you remember the correlation between moment and load. We've done it 100 times. Moment equals force times distance. How does that apply to this problem? Moment, MU, equals PU times E. E is a distance from the center to the load. So there's the equation you need right there. You need MU is PU times E. If I get MU, I've already got PU. Divide the two, I have E. So let's look at MU. MU equals 1.6 times 30 plus 1.2 times 25. So if I multiply those two out, 1.6 times 30 plus 1.2 times 25, I get 78. Is that right? 78. If I put those numbers into my formula I just developed, MU, 78 foot kips. PU, 248 kips. If I divide 78 by 248, I get 0.315. Y feet? Foot kips. Kips, divide, kips cancel, feet left over. What is my units? Inches. How do I get from feet to inches? I multiply it by 12, and I get about 3 3/4 inches. There's my second number. So we've got 248 kips. So I'm going to look at the tables. And what they say my specs are. My specs for this are 5,000